All right. Hello, thank you for taking time to be here with go over my capstone. My project titled Using Machine Learning to Predict Social Media Engagement. This project focused on exploring how machine learning techniques can be used to analyze social media engagement data and identify the factors that influence engagement outcomes such as likes, comments, and shares. The goal of the project was to create a more practical and data-driven approach that can help content creators make more informed decisions when posting content online. This presentation will provide an overview of the capstone project, including the problem statement, motivation, and background of the research topic. It will also discuss related work from prior research studies, the proposed approach and the system design, implementation planning, data collection methods, and data analysis techniques. Finally, the presentation will conclude with references and question and answer section. Social media engagement can be difficult to predict, and many creators rely heavily on trial and error when posting content online. Because of this, it can be challenging to understand why some posts perform while others still receive very little interaction. Social media platforms generate large amounts of engagement-related data every day, including likes, comments, shares, hashtags, posting times, and user interaction metrics. This creates an opportunity to use machine learning techniques to better understand engagement behavior and identify measurable patterns. This project focuses on developing a practical and simplified predictive approach that can help creators make more informed and data-driven decisions instead of relying mainly on guesswork. Previous research shows that social media engagement is influenced by several measurable factors, including content type, posting time, sentiment, and user interaction patterns. Researchers have also used machine learning models to analyze these factors and improve prediction accuracy across different types of social media data sets. Prior studies also demonstrated that sentiment analysis and behavioral forecasting can improve predictive performances and help identify recurring engagement trends. However, many existing machine learning models remain technically complex and are often designed primarily for research or large-scale commercial environments. This project aims to help address that gap by focusing on a more practical and user-friendly predictive approach. This slide outlines the overall workflow for the project. The process began with collecting social media engagement data from publicly available data sets. This data included likes, comments, shares, hashtags, posting times, and content categories. After collection, pre-processing techniques were used to clean and organize the data before analysis. Feature engineering was then performed to identify the variables that most strongly influenced engagement outcome. A random forest classifier was trained and evaluated to predict high and low engagement outcomes based on post characteristics. The final goal was to create a practical predictive work that could help users better understand engagement behavior and improve content strategy decisions. The design of the project focused on creating a machine learning workflow that supports engagement, prediction, and analysis. The workflow includes several stages, including data pre-processing, feature engineering, model selection, prediction, generation, and evaluation. Data pre-processing was important for cleaning and organizing the dataset before analysis, while feature engineering helps identify the variables that contribute most strongly to engagement outcomes. Different machine learning models were compared to determine which approach provides the best prediction, performance, and reliability. The implementation phase focused on developing the predictive workflow using Python and machine learning libraries. Several tools and technologies will be used throughout the project, including Pandas for data manipulation, skitlearn and for machine learning model development, and Jupyter Notebook for testing and experimentation. The implementation process included data cleansing, feature selection, model training, and prediction analysis. The project used publicly available social media engagement data set that included metrics such as likes, comments, hashtags, posting times. After the data was collected, pre-processing techniques were applied to clean and organize the data set. It includes removing duplicate records, handling missing values, and converting the data into formats that can be used for machine learning analysis. The overall goal of the data collection process was to identify engagement patterns and prepare the data for predictive model training. The data analysis phase examined engagement-related variables, including likes, comments, shares, saves, reach, and impressions. Exploratory analysis was used to identify trends and relationships within the data set. A random forest classifier was then trained to predict whether a post would achieve high or low engagement based on its characteristics. Model performance was evaluated using accuracy and classification metrics, while featured importance analysis identified the variables that contributed most strongly to engagement predictions. The findings demonstrated that machine learning could identify meaningful relationships within social media engagement data. Variables such as likes, reach, impressions, comments, and shares contribute significantly to prediction performance. The random forest model successfully classified posts as high or low engagement and provided insights into which variables had the greatest impact on engagement outcomes. Project demonstrated that machine learning could be used to analyze social media engagement and identify patterns associated with successful findings or some successful content performance. The results show that engagement is influenced by measurable variables and can be incorporated into predictive models. These findings supported the use of data-driven approaches to help creators make more informed decisions and reduce reliance on trial and error posting strategies. And finally, I'd like to do a demonstration to show what I have created. First, I loaded the libraries using the pandas and matplotlib, squared, then loaded the data set, which was the Instagram analytics from next thing I did, I reviewed the data set to see what was in it, then cleaned the data. Saw there was 29,999. Once cleaned, there was only 19 columns because there was one column that did not apply. Created the target variable, whether it's high engagement, and encoded the category so that it can be the non-numerical values could be evaluated. So you have media type, content category, traffic source, and day of the week were all numerical valued. And selected features, which were used to determine what gave the highest engagement. And this was in our slide. And created a model using a random forest classifier. And here's what we got. And evaluated the model to get to a 98% accuracy. And printed the report for classification. Used the confusion matrix to see how good it was. And feature importance graph. And the most important thing was likes. And then plotted the factor as you can see how many more likes were that gave the best engagement. And then gave a sample prediction, which came out to be high outcome. And then I have my sources. Oops, that wasn't supposed to share. Sources. And that was the whole presentation for my project. So thank you for the time and the opportunity to present my capstone project.
Uh, Thank you so much, Douglas, for presenting. It's a very good project. Hope we get to know what brings the engagement on social media. It's very good thing.
Yes,
Yeah,
thank you.
you're welcome. Someone like to present next?
I think it's my turn. Um, yeah, let me go ahead and share my screen. Give me a second. Hmm. Okay. Bring it down.